Hi everyone, I'm Jeff Camm. I'm the Associate Dean of Business Analytics, and it's my pleasure to speak with you about the future of work in a data-driven economy, especially with regard to analytics, artificial intelligence, and automation, and how they might impact how we work in the future. It's good to have an understanding of what we mean by these three terms. Analytics is the scientific process of transforming data into insights for making better decisions. So it's about how to use data to improve decision making, very general definition. Artificial intelligence is the theory and development of computer systems able to perform tasks that normally require human intelligence. And that's very much a hot topic these days. There's a lot of anxiety, a lot being written about how artificial intelligence might get out of control or take over the world, that sort of thing. We're going to talk a bit more realistically about what artificial intelligence really is right now and how it might be used. And then automation. Automation is the use of equipment in production and services, and we're going to focus primarily on robotics there. So analytics, artificial intelligence, and automation, how are they going to change the economy and how we work in the future? And we'll start with analytics. So we've given this definition. We actually have a strong master's program in analytics, both an online version and an on-campus version, in particular business analytics, and I oversee those programs in the School of Business. And so we focus particularly on business problems. And so how do we use data to make better decisions for business? And analytics really exploded in about 2007. And the reason for that is just how much data we generate now. So 25 quintillion bytes of data are generated per day. That's 2.5 times 10 to the 19th. 30 billion devices will be connected by the end of this year. 30 billion devices, phones, computers, the sensors, for example. We'll talk more about that. So social media, the Internet of Things, all these are generating overwhelming amounts of data, and business and other organizations want to know how to use that data to become more profitable, to better serve their customers, to drive innovation. And so the fact that so much data is being generated now, that has really led to the analytics revolution, if you will. So let's talk about some ways you might see this surfacing in everyday life. So I'm sure you've seen one of these Coke machines where you can mix your own drink. So you go up with your cup and you put your cup into the machine, you get some ice, and you can press any mixture of buttons you'd like to make a concoction that best satisfies your taste. And this is an example, by the way, of mass customization because of automation, essentially. We can choose any drink we want. We can mix it up differently every time we go to the machine, and so we can give the customer exactly what he or she wants. Interestingly, these are connected to the internet, and so every time someone makes a drink, that data goes back to Coca-Cola. So Coca-Cola is able to collect these data and better understand what people are choosing. So the old way of developing a new product might be to, in a lab, try to develop a new taste, then take it to some market research where they do focus groups, etc. Here, they're getting real-time data on how people are mixing these drinks, and consequently, they have a sort of a built-in market data collector, if you will. And so last spring, you might have seen a television commercial where an orange truck, vanilla ice cream truck, and a Coca-Cola truck all come to an intersection. They collide, and down the street rolls a can of vanilla orange Coca-Cola. I suspect that product came out of the data from these machines where they noticed a frequent mixture was vanilla, orange, and regular Coke. Similarly, John Deere, which is a manufacturer, they manufacture farm equipment. They no longer just sell farm equipment. They sell farm equipment that has sensors in it. And so when you use that farm equipment, sensors are collecting data from your soil. And what John Deere will sell you is not just the farm equipment, but also a service that analyzes your soil and gives you a plan, if you will, for planting to maximize your yield. It might involve how to better irrigate, how to rotate crops, etc. All that comes from data collected through the sensors. So we have a traditional manufacturer who's realized that data and collecting data from its own product that it sells is a very valuable resource. And they built a new product, which is a service around that data. Similarly, again, both of these would fall into the category of the Internet of Things. GE Aviation makes aircraft engines, and they put sensors in those aircraft engines. And so every time an airplane takes off powered by a GE engine, data goes back to GE's headquarters, and they now will sell you a plan based on that sensor data, a maintenance plan. They even will sell you a plan for better flying to be more fuel efficient. So similar to John Deere, a manufacturing company, in this case GE Aviation, has figured out how to collect data through the product they sell and create a new product based on the analytics. So changing business dramatically. So demand is up for analytics expertise in industry, and a consequence of that is there's been an explosion in master's programs. So here we have a graphic from North Carolina State University. It keeps track of the number of master's programs in data science, business analytics, and data analytics. And you see there's been an explosion just as industry has demanded more highly trained, data-driven professionals. Academia has responded with more master's programs, and so we now have north of 250 master's programs in the U.S., whereas in 2011 there were just a few. This is just a little graphic that using data from the internet on jobs that shows how in demand, open positions in thousands, how in demand analytics, data science folks are right now. And so it's definitely a growth area of the economy, and it's allowing companies in the economy to be more efficient, to be more service oriented, to be more profitable by being smarter with data. This is a little graphic of companies who have hired from our Master of Science in Business Analytics at Wake Forest in the School of Business. We've just graduated our 4th class, and we're very, very proud of the companies who have come to our program to hire our graduates. Our program is really a mixture of methods, analytical methods, which are critical, professionalism, communicating effectively, and driving change is very important, and then business acumen. So our students, when they graduate, know a fair amount of business content as well. And so companies have gravitated towards our program, and our alumni network, by the way, also has been superb in helping us place our students out of this program as it's growing. So I want to talk a little bit about a project I was a co-author on to temper sort of the focus on the technical for a moment. What you see here is a bar chart that gives a listing of buckets of terms that appeared in over 600,000 job ads we did text mining on. So we studied over 600,000 job ads in analytics and data science, and we searched for terms, and it turns out this top category is communication and interpersonal skills. 60% of the job ads mention something in this term bucket, something about communication or interpersonal skills being required for the job. Next was managerial skills, database skills, not surprisingly. Business knowledge is very important. And then finally, you have to be down in the fifth spot before you get to modeling and analysis, the more technical side. So there seems to be this, in the context of analytics and data science, a desire for essential skills like communication, teamwork, managerial skills, and it pops up, prevalently in a very prevalent way in these job ads. And so we might be thinking, well, maybe that's true of all jobs. So we looked at other job categories, and my favorite one to take a look at here is teacher K through 12, second from the bottom. Only a third, roughly, of those job ads mention communication and interpersonal skills. We know those are important for teachers, but they're in almost two-thirds of the analytics and data science jobs. I think it's because it's recognized as a gap. So you have to have technical skills to be in demand in a data-driven economy, but at the same time, there's a recognized need. You can't leave behind the people skills. You have to be able to work in teams. You have to be able to articulate a plan and a recommendation and why the analytics drives recommendation and consequently impacts decision making. So you really need this mix of technical and people skills. So I want to make sure that it's clear that we're not saying technical skills win the day. The people who are going to be successful in this future of work are going to be technical people who are also business savvy and possess interpersonal skills. So that's analytics. What about artificial intelligence? So artificial intelligence, again, it intersects with analytics, but it's different. It involves things like facial recognition, autonomous vehicles, etc. But all that uses data, but there's a little bit more of automation involved in artificial intelligence. So a lot of machine learning, I would say, where you build a model to predict something and it evolves over time as more data comes in. That's sort of at the intersection of analytics and artificial intelligence. So how is AI going to impact the future of work? This is from the Future of Jobs Survey 2018, which comes out of the World Economic Forum. And we have trends that positively impact business growth by 2022 and trends that negatively impact. And I think it's interesting that artificial intelligence is in both columns. So artificial intelligence may cost us some jobs, things that can be automated easily that might now even be white collar jobs, like auditing, for example, might be automated with artificial intelligence. At the same time, artificial intelligence is creating jobs. So there's a strong demand for data scientists. So, I guess the question is overall, is AI going to lead to net positive job or net loss of jobs? My opinion is it's going to be a net positive, but like everyone else, I have no proof of that yet. These are examples of some roles in the new data-driven economy. And again, just briefly, you can see in the middle column, new roles: artificial intelligence, analytics, data scientists, big data specialists. These are all digital transformation specialists. These are all very analytical kinds of jobs. And so it's clear there's going to be every worker almost, I think, to really do well is going to have some level of analytics or data savviness or proficiency, let's say. What kind of roles are going to be redundant or going to go away? Well, things that are automated. Take the first one there, data entry clerks. Well, we're collecting data now automatically through the Internet of Things. So very few people are manually entering data anymore into a database. Auditing, I mentioned, is about a quarter of the way down. So a lot of things that are automatic now because of the technology we have, or because we're smarter in how we work because of analytics, a lot of those jobs are going to go away. Interesting one there at the bottom, lawyers. So can technology and artificial intelligence, is that going to negatively impact the law profession in terms of the research that's required to try cases, etc.? Okay, so what about our third big topic, automation? and I want to focus on robotics, but as I already mentioned, as analytics intersects with artificial intelligence intersects with automation. So when you think about robotics, embedded in a lot of robotics is artificial intelligence, where some process is followed, and as more data is collected, a robot adjusts its behavior as it learns. Facial recognition, a good example. So, unlike artificial intelligence and analytics, automation, we have some history on automation. And so I want to first start with a few examples here, but then talk about the history of automation and what we can learn from that about how it changed work. So here, Germany has been a leader in robotics, and they actually saw a net increase in jobs because of automation led to, for example, decrease in prices and demand goes up, that sort of thing. Efficiency, other types of jobs are created where you're now programming robots, etc. But they saw a net increase in jobs as robotics increased. In the US, we're seeing a shift in manufacturing because of robotics, a shift in the educational requirements of manufacturing jobs. So what maybe before was just required a high school diploma, now maybe requires, because it's more technical and involves a computer, maybe requires an associate's degree in computer technology to program a robot or drive data dashboards and quality control, those sorts of jobs. So we're seeing automation change the skill set required or needed for manufacturing. In the U.S., there have been some studies. I think they're not rock solid, so no one really knows. I think, in my opinion, we don't have enough data to really say with certainty what's going to happen. But there has been a study that shows a 47% job loss because of automation. But we shall see if that really occurs and what other kind of new jobs are going to pop up. Maybe we haven't even thought of those yet. So no one really knows for sure. But if we look back at history, there's some automation that's taken place, and maybe we can be a little more optimistic. So automated teller machines disrupted banking. We used to have on average 21 tellers per branch in the banking industry. And when ATMs came, that dropped to 13 tellers per branch. But as branches became cheaper, there was some synergy there. Branches became cheaper. The overall number of tellers actually went up. And people skills became more important. There are people, I know some of them, who will not use an automated teller machine even to this day. They want to go in and speak to someone. And so to map it back to what we were saying about importance of people skills, automation here led perhaps to an increase in people skills to differentiate a teller from an automated machine in a typical branch. The textile industry is another interesting example. In the 19th century, as textile production was automated through looms, prices dropped, and there was some job loss. But then because prices dropped, because of the automation, demand went up, and there was a net increase in jobs in the textile industry, even though they became automated because demand was so strong as the price dropped. A more modern example, Uber and Lyft, they disrupted the taxi industry. And you might think, well, that must have put a lot of taxi drivers out of work. And if you measure just traditional taxi drivers, that was probably true. They were disrupted. But if you count, I'll put taxi drivers in quotes, if you count people who are driving other people around in their car, that is, people who are driving for Uber and Lyft, the number of people serving as taxis, that is, making money by driving other people around in their cars, it actually tripled in 10 years from 2008 to 2018. So more jobs were created because of Uber and Lyft, more jobs in that space, if you will. So what about this idea from automation that, in AI to some extent, that if you have more education, you're less likely to be automated. You lose your job because of automation, or for that matter, because of artificial intelligence. And this is from the Wall Street Journal in the last 6 months or so. I think it's the second sentence is what caught my eye. It says, for instance, college professors can be replaced more easily than kindergarten teachers. And the idea here is that empathy is not something that can be automated or easily replicated through artificial intelligence. And so the notion is that college professors are less empathetic than kindergarten teachers. I don't subscribe to that personally, but that's the idea. So it maps back to what I was saying much earlier, which is these people skills, they're going to remain key. Those are things that can't be automated. Again, the ability to be creative, to identify and define a problem as opposed to solving a problem with analytics or data science. Those are critical skills, and they should not be, don't think that those are going to be automated. A very recent article caught my attention because it has automation and AI and analytics really embedded in it. This is from Tom Davenport, who is actually professor at Babson College, who really had a big part in driving the analytics revolution. He wrote a book called Competing on Analytics that came out in 2007. But in this article, he talks about Morgan Stanley using artificial intelligence and this thing called the next best action. And they're using that with financial advisors. And it drives home the point that I've made a couple of times now, and that is there are some things that they're finding artificial intelligence is very helpful with in terms of financial advisors, like if the market changes by so much, an automatic email goes from the financial advisor to his or her clients with a message that maybe how it impacted their particular portfolio and would they like to have a call, for example. But the bottom line is that financial advising is very much a person-to-person industry, and so the call still is there. So the connectedness is enhanced by artificial intelligence, but the person-to-person connectivity that is required has not been diminished. And so it maps back to this idea that many things can be automated, many things can be improved through analytics and the use of data. Some things are going to remain, and that balance between technical and people skills, or some people call them essential skills, is going to remain in a data-driven economy, and in fact separate. Again, I think it's what's going to separate the people who have technical skills and these essential skills are really going to thrive versus someone who's just technical, or someone who has the people skills and is not technical. I think you're going to need both in the future. We're winding down here, so I wanted to mention this because I just think it's interesting when you worry about automation and artificial intelligence and getting loss of jobs and that sort of thing. There's a little graphic that shows by several different European countries how the work week has changed. Average hours in a work week has changed over time. So you see the beginning of the graph is 1870, and then it goes out to 2000. But you can see that the average work week back around 1870 was up to almost 65, 70 hours a week. And there's been a lot of automation that's happened and technical developments that's happened over time. And now we see that the average work week in these European countries, at least, is getting closer to 45 or 40, down in the 40s at least. And so there's nothing magical about, now we expect a 40-hour week at least, right? But there's nothing magical about a 40-hour week. So if artificial intelligence and automation and analytics improve the efficiency so much you think, well, a lot of people are going to lose their job, maybe what we'll do is just shift what a work week is. Maybe if we extend this out to 2090, that an average work week will be 35 hours or 30 hours. So we don't have to work 40 hours a week. We can still get the same pay if we still have the same output. It's just more efficient and no one has to work as much. And in fact, that'll lead to more leisure time jobs, right? More, let's say, amusement parks and restaurants and bars because we have more free time, gyms. It'll lead to more jobs perhaps because we have a lower number of average hours in the work week. So a lot of this is all intertwined. So here, again, this is from that World Economic Forum, top 10 declining roles, top 10 emerging roles. We've seen these, this list before, but I just wanted to highlight it again. Things that can be automated that, are repetitive or rule-based, those are declining in demand, and those that are more data-driven and more technical seem to be increasing in demand. But I would caution that you have to still really be able to influence working teams and the whole process of what should we work on with AI and analytics. That's a very creative process, a process that probably can't be automated. So what have we learned? People skills will remain important. They may be augmented with artificial intelligence like they're doing at Morgan Stanley. Analytical skills are going to be critical. So I think if you're a business school graduate, and you're going into the marketplace, you better be data savvy. You better be rock solid, for example, in Excel. There are now MBA classes in Python and artificial intelligence and R programming. So definitely a shift to more technical. Doesn't mean leadership or creativity or teamwork are less important. It just means you also need to be data savvy. So problem solving skills are critical. The reality is the technical side is changing so fast that people are starting to talk about the 60-year curriculum, which I suppose is very good for universities. The idea is you're never going to stop learning. You're going to have to adapt new technologies, new ways of thinking. So it might not be a degree, but it'd be continuing education, certificates, modules of learning, even using artificial intelligence to generate coursework, for example, and deciding if a student needs to go to course A or course B next. So all that's going to be very, very important. And then what I ended with there's nothing sacred about a 40-hour work week. It might be that all of this leads to, in fact, a work week that is lower in average hours. Let's root for that one. So it's been my pleasure. Thanks for sticking with me through this video. Here's my email address. If you have any comments or have an interest in analytics or artificial intelligence in particular, feel free to reach out to me via email. I love to chat with you. And thanks a lot for listening.